Today I'm going to make the most simplistic rock, paper, scissors game that I can come up with in Python. If you're experienced programmer at all, you're probably going to think, oh, I think I could have done some of those things more efficiently or better, but you should do that. I am just trying to make something simple that people can follow through, so I had to make some decisions about what I think is the easiest way to do this, and that's what I'm doing. So I'm over here in Replit. I'm going to create a new REPL, and it's going to be Python. You should give it a better name than Joyful Grimy Wheel. As you can kind of see, like down in here, I run out of names. I already did something called Rock, Paper, Scissors. So yeah, I'm going with Joyful Grimy Wheel. You should definitely give it a better name, but what do I call it, right? When I've done this for the 5th time, I don't know what to call it. Alright, so I'm going to start the way that I should always start, which is by putting my name and a description of the program. Rock, paper, scissors, game. The more information you put up here in the comments, I don't know, I guess generally speaking the better, but I don't really know what to do when all I'm doing is that. Alright, so the way this is written, I'm not going over the specifications. There's a PDF of those, and the solution video kind of makes sure that they're going to get covered anyways. I also want to just state before I actually get going, again, if you don't need this video, great. I'm sure you could do a better job than what I'm going to do. I'm doing... What did that autocomplete? Game. Alright, I got auto-completed. Anyways, I think you could do better than this if you wanted to, and this is just to help people who are having a hard time doing it. And like I've said, I'm trying to do it with like the minimum amount of concepts, even though I know it's not going to be perfect. Alright, so what we're going to be doing is we're going to be tracking statistics. So like how many wins, how many losses, how many ties. So that means we're going to need to create some variables, initialize them all to 0, because in the beginning you haven't played any games, you haven't lost any game. You haven't tied any games. Alright, those are our variables, which are going to represent our game statistics. I could comment those out, I guess, but I think they're pretty obvious what they are. But that's what a comment would look like. So we've got to get into some decisions right off the bat. I'm going to create a variable called GameOn. This is going to serve like a Boolean, but I'm setting it to a character. So basically, the game, you're going to keep playing games. When you play rock, paper, scissors, you don't just play once, usually. You know, you'd hit once, and it's best of 3, best of 5, best of 7. So that's what's going to represent whether the game is still going. So I'll say something using this like a flag. A flag is a Boolean, so 1 or 0. I'm just trying to make this thing easy for people to follow. When I did my first draft of this, I definitely made it a Boolean. But like I said, I'm not trying to do the most defensible or pretty design choices. I'm just trying to do the thing that is going to give me the least resistance. Alright, I think that's all the housekeeping I need. Now I'm just going to jump into a loop, and this loop is going to determine, like, do you want to keep playing? Do you want to keep playing? Do you want to keep playing? I've already decided we're playing one game, so I'm going to use a while loop here. So while game on is equal to y. Alright, so as long as that y is there, this game's going to keep going forever. Inside of this loop, notice a little bit of indentation right there. Inside of this loop, I will ask them if they want to play again at some point, but that's a ways down, I guess. It's actually going to happen at the very bottom of the loop. So I want to check, does rock beat paper? What did the user choose? What did the computer choose? I got to do all that stuff, and then I want to then I want to ask the do you want to play again question. It doesn't make sense to ask that question here, even though I'd like to, because I know where I'm going with this. Alright, so where I'm going with this. So the first thing I want to do is I want to create a random number for the computer. So this is going to represent the computer's choice. And this isn't going to work perfectly, so CPU, whatever you want to call it, right? It's a variable. What's not variable is random.randint. So I'm going to do a number from 1 to 3. So it's going to be like 1 is rock, 2 is paper, 3 is scissors. Notice that doesn't work. Well, the reason that doesn't work is if you want to do random, you need to do import random. when I'm trying to do things simple for a demonstration purpose, there's always chicken and the egg situations, right? Do I write that knowing that's the first line of code I need, or do I write it later? Well, I just wrote it later. I wanted to tell you why. All right, so that's the computer's choice. It's going to be an integer. And here's a cheat that I like to do. I'm telling you, I pretty much think this is mandatory. I think for testing and development purposes, I think you need to write out CPU choice. And so I'm doing a little concatenation here. I'll talk about what I did for a second. So I'm printing out the CPU's choice because you can't test this thing worth anything if you don't know what the computer chose, right? So the way this works, it's going to say, hey, the computer chose paper, and then I can choose scissors and make sure that they win. Then I can choose rock, make sure it loses. But if I don't know what the computer actually chose, I can't test this thing worth anything. Also, I had to wrap this thing in a string because it is an integer, right? Rand int, meaning this is going to be an int. I know it's one of the annoying things about Python, but you have to convert it to a string right there. So in the final game, real game, I'll take that out, but for testing, I kind of need it. All right, so the computer has made a choice. I've printed out the choice. Here's what else I'm going to do. I'm also going to see this games variable. At the point where you pop into this loop one time, I'm going to say games equals games plus 1. So add 1 to games. Right? Because you just you're playing a game right now. And every time you take a trip through this loop, it's going to add 1 to games. Now I'm going to ask the user for their choice. This is an ugly string, and I don't know what you're going to call this choice. I call it player because it's like the player's choice. All right, it's going to be an input, and I don't know the best way to do this. It's got to be a pretty long sentence. It's, choose your weapon. I don't know what you can say whatever you want. I don't care what you say. Choose your weapon, but then we got to come up with this. How are we going to communicate to them like rock, paper, scissors? I do it like this. Rock is 1. 2 is paper. Does this actually make sense to a user? I don't know. It might not. But we've got real limitations at this point because we haven't written a whole lot of code, and I definitely haven't done a lot of programs, and it's probably a bad idea to even try to do a program that has this much going on at the point where you haven't written a lot, but that's also why I made a solution video. So is that going to work? So I'm expecting a 1, a 2, or a 3 based on the player's choice, and I guess that'll work. So just to tell you, like if they type rock, it's not going to work because I'm looking for 1s, 2s, and 3s. If they do R, it's not going to work. So that is generally called data validation. If we were going to do a way better job with this, then we would find a way to validate that data, like only tolerate what we're expecting, like 1s, 2s, and 3s. But that adds another level to this that I don't want to do. Well, I mean, I do want to do it, but I don't want to make people do it who aren't comfortable with that. So I'm just going to leave it like this. And I know that if you don't actually type 1, 2, or 3, this whole thing's going to go crazy. All right, so this is one of the more complicated parts. So let's just deal with it right now rather than before it becomes an issue. See how this computer's choice is an integer? Well, anything that comes from an input is a string. So at some point I'm going to compare the computer's choice to the player's choice. And when you compare a string to an integer, that doesn't work the way you expect it to. So if this is an int, I'm going to turn this into an int. That means I'm going to wrap this whole thing in an int, like that. So I'm going to convert that to an int. Just because you need to compare integers to integers, strings to strings, it's not real clear why I did that, but trust me, it needed to be done. Now here's where it needs to be done. So if, and here we're just going to work through all the possible things. Now there's only one smart thing I can think of to do, and that is, I'll say CPU equals player. Actually, I like writing player first. Now, caps lock. So if player equals CPU, that means tie. That's the easiest one. And so that's like a powerful one to start with because you're checking rock versus rock, paper versus paper, scissors versus scissors. You just caught 3 cases right there. And so that's going to be print tie. And what I would do is also say ties equals ties plus 1. Now, believe it or not, at the point where I've done that, we're like, I don't know, 75% of the way there. From this point, Notice when I press enter, I'm indented a little bit. I backspace to unindent. Right, this indentation here defines the scope. Now it's time for about 1,000,000 LFs. So I'll just work through like, so if player equals 1 and CPU equals 2. Right, you don't need to check for CPU equals 1 because you already got it here. And so what the heck does that even mean? So using this scheme here, that would mean player chose rock, computer chose paper. Well, that would mean you lose. So we're going to have to write out that lose. So you lose, and I do want you to be descriptive about it because otherwise it just feels like you're generating random numbers. So paper beats rock. And since that was a loss, I'll say losses equal losses plus 1. And then, so I press enter to go down. I backspace to get my indentation correct. So LF player equals 1 and CPU equals 3. At this point, I've literally worked through all the possible player chooses rock scenarios. So that's going to be rock, smashing scissors. So print. Oh, you win. Sorry, you win. Rock beats scissors. And that would be a win. So wins equals wins plus 1. Sure, you could do things like plus equals 1. Do you remember in the beginning when I said if you think you could do a better job of this, you probably can? Look, I'm sure you can, and I don't even care who you are, where you're from, or what you already know. I'm sure you could do a better job than this. I'm just trying to write this in the most straightforward way possible, so those folks that are feeling lost about everything can follow the best they can. Now, believe it or not, at this point, it's just wash, rinse, and repeat. And as such, look, I get it. I just said if you're new to this and you're copying me, that's okay. Look, even if you're new to this, even if you are copying me, you should be able to see where this is going. Next up is going to be if player equals 2 and CPU equals 1. Right, you're just going to run through all the various combinations. Now in the instructions to this, I gave you a little table and I said fill it out. That's kind of where this goes. It's just translating this into that. So I'm going to pause this, and then when I come back, all my LFs are going to be filled out. And if you need to copy them, you can, but I'm telling you, you could do this. You just got to look at the numbers and do a bunch of LFs. The only thing that's going to be nasty about this is going to be the indentation. I'll show you what I mean. Because my instinct right now is saying, hey, I like that. Right? Why not kind of steal those or reuse them? Here's what happens if you paste them. I just want to show you kind of what you're in for. Oh, actually, that went perfectly. I was thinking that it was going to be all crazy, like indented like that, which would not be good. Anyways, like I said, I'm going to go wash, rinse, repeat. It'd be great if you are new to this and you could figure out the rest of them or try, but I'm going to pause it. I'll be back, and the rest of my LF cases will be done. All right, so I just kind of filled in the cases like 2, 1, 2, 3. I actually don't really, this doesn't make much sense to me. I got to look them up. So 2 is paper, 1 is rock. That would be you win. I guess. Wait, so rock beats, or sorry, paper beats rock. Yeah, okay. And then wins. I know I said I was going to finish this, but I figured some of you were going to be trying to copy off me anyways. So I did the structure, and now I'm just going to reevaluate it, walk my way through it. So 2 and 3, that's paper versus scissors. That means you lose. Scissors. Wait. Scissors beats paper. And then it's scissors against rock. That's going to be a lose. Wait. Yeah. Rock beats scissors. I'm probably not even, one of the reasons I'm showing you this quote approach is that fixing these, like I kind of copied the shell of it, you could tell, but going through and having to think about what needs to change is probably actually, it's not really saving me any time at all. Wins, losses, Lost it. Do you see all? It's like all these things need to get changed. That's the tax you pay if you were going to copy and paste even your own code. Alright, I think this works. I think I got all my cases covered now. I might have some logic errors in here. I don't actually know. And then the last thing that needs to happen inside of this loop is this whole game on thing. So after the game is over, I'm going to say game on equals input. Do you want to play? I don't know. I don't play again. Enter Y. Or see, I don't know the right way to do this. I feel like that's not the right way, but I don't know. So we're not completely done yet, but let me test this thing. It should run. Actually, I would have been doing myself a huge favor if I ran this thing after I wrote each one of these cases. But I didn't do that. Alright, so here's my little preview. I've got that ugly no colon thing right there. I always complain about this. I think you pretty much need to do that, otherwise it looks like it's tacked onto the end of the sentence. So computer chose 1. See where I'm using that little cheater line? So let me try this with 1 and let's make sure I tie. Tie. Do I want to play again? Yes. Computer chose 3, so scissors. So let's try beating. Scissors with a rock. Okay, that seems promising. Yes, I want to try again. Computer chose 2, that's paper. I haven't tried losing yet. You see, I actually have to think about this because rock, paper, scissors is weird. Paper beats rock, right? That's a hard one to stomach. So I tested it 3 times. I think it works. You see, I think it works. Ideally, you'd test all the cases, but the reason it's kind of painful to test is the computer keeps choosing something random, and how am I supposed to track what I did? Now you just wrote this program, and you may have made some mistakes, and heck, I may have too. You should keep testing it. But I've already written the whole thing, so I'm not that worried about testing it more. Here's what I'm going to do. See this print CPU choice? I'm going to comment that out, because it doesn't make sense to have that going anymore. Alright, so it looks like we've got a game that works. Now here's the thing. The last part of this is we need to shoot out our statistics. So, alright, notice I'm inside of a loop here. If I backspace, now I'm out of that loop. So this line right here, for me it's line 47. For you it might be line something else, depending on whether you have comments or white space. But down here outside of the loop, I'm going to print out the game stats. This is going to be painful. And I'm sure, oh my gosh, stop that. I hate autocomplete. I just do. I never use it, so really don't like that. Alright, so it's going to be a big old print down here. Huge string. It's going to be whatever games won, whatever games lost, whatever games tied, whatever total games. And so this is going to be painful. So the first thing I want to say is how many games they won. So that's straight starting off with a variable. So wins, games won, like that. Let's see how that works. No. Alright, so it blew up. So here's the problem. It's this messy thing I was talking about. So it's related to this problem. You remember we had to make this an int because this was an int and this was a string, and then, right, the lack of similarity in the data types causing us some trouble with our comparisons. Well, we get bit by that right here too. So you have to put a string, you have to make that wins into a string. Now if I run this thing, you see now I kind of get what I want. So these integers, all these things here, are going to need to get converted to strings, which is super annoying. Combine that with the concatenation, and you got your hands full right here. Plus, what I was going to say next. Something games lost, so str losses. You notice I did the type conversion on the fly. Games lost. Next up is going to be ties. STR. Ties. Games tied. Oh, I know. Trust me. This is pretty bad looking. Space after that. Space after that. I'm trying to put spaces in here because when you're doing a bunch of concatenation like this, it's not going to turn out the way you wanted. And then the last one's going to be something about like total games. I might have some mistakes right now. That's okay. I don't care. I think it's called games. Yeah, it's called games. And we'll see how that goes. I don't know how that's going to go. Maybe good, maybe not. 0 games won, 0 games lost, 1 game tied, 1 total. I don't know. That seems good. Now, the only thing about this that bothers me a little bit, well, a lot of things bother me a little bit, but this whole tie thing, I'd kind of like it if it said tie. You know, you both did scissors, you both did paper, you both did rock. However, I can't really see a good way to, well, an easy way to do that without having to do more work than is probably needed. All right, and that's rock, paper, scissors. That's one way of doing it. It's the easiest way I could come up with it. So the big flaws here is there's no data validation. Like, so for example, let's say I do 4. How do you think that goes? I don't know what it does. You know, and do I want to play again? Yes or no? Well, here's a fun one. If I do R, like it's only looking for a Y. Literally anything other than Y doesn't work. It just breaks you out of the game, which I guess I'm fine with. That's that idea of data validation, though. And the same with, like, choose your weapon. And also, I just saw a typo up there. Enter Y or S. And your. Alright. Well, I think this thing it works now. I mean, you got a rock, paper, scissors game. It goes until you want it to stop. If you wanted to add data validation, you should. If you wanted to make some of these messages more verbose or interesting, knock yourself out. It's all good. Like I said, this is just the kind of the minimum, I guess, for getting through it. And anything you want to do beyond that would be good for you. And probably, hopefully, fun. All right. So when you're done, you'll share this thing. That's what you'll submit. And that's the assignment. Thanks for watching. I hope it went well.